Colour. We're going to start by looking at colours in the real world. So the spectrum that we get when we split light with a prism or in a rainbow, the colours are always in the same order. So if we use the imaginary scientist name Roy G. Biv, that allows us then to make sure that we've got all of those in the correct order. So when we look at our RGB colour model for computers, they are still in that same order. So we always start with our red, we're not going to worry about orange and yellow, green, blue, and then we've got the indigo violet. So we're going to use these three colour channels to represent colours on a computer. So this is called the RGB colour model. So there are different colour models used for computers, for monitors, for televisions, for printing and so on. RGB is probably the most common one used. Red, green and blue are the primary colours for light. So in order to look at this, let's imagine that we've got three huge spotlights. We're all sat in a cinema with the lights off, so we're all in the dark. Each spotlight has got a dial on it going from 0 to 255. So if it's 0, you've turned the light off. 255, it's as bright as it can be. We turn all of the spotlights to full, and then we're going to move them so that the circles of light overlap with each other. So at this point we can see where the circles of light overlap, we then get different colours. And the colours should always be brighter than the three primary colours because we are adding more light to them. So here's our colours. So we've got our red, green and blue primary colours, and we've got our cyan, magenta and yellow secondary colours. If we mix all three colours, we get white light, and if there's no colour at all, where things are switched off, then we get black. So at this point you need to load up the O1 RGB Colours 1, answer the questions. Pause this video, load up the colour triangle that you've got in your folder if you need to do, and then when you've completed that, come back to the video. So now we're going to have another look at this colour triangle and start looking at some of the RGB values. So each of the RGB values goes from 0 to 255. For primary and secondary colours, and for white and black, we only need two numbers for each channel, which would be 0 or 255. So let's start by having a look at what the RGB code for red is. So up here, where we can see the red is on full, so that would be 255. Now let's look at the green channel. The green channel is this circle here, and if you notice it ends there and does not come into this area for red. So that means that the green value is 0, because there is no green needed up here to make red. The blue channel is this circle of light here, and again, when we're up there in the red, none of the blue is coming up here, so its value is 0. So our RGB value for red is 255, 0, 0. And that's what we expect, because red's a primary colour, we don't need any other colours to make that colour. Let's have a look at the RGB code for yellow. So we can see yellow in this area here, and we can see that yellow is inside the red circle of light. So it must be 255 for the red channel. Yellow is also inside the circle of light for green, so it must be 255 for green. But yellow is outside this circle of light for blue, so the blue value must be 0. So our RGB code for yellow is 255, 255, 0. Pause the video here, load up the second set of questions and answer those, and then come back to this video so that you can answer the rest of the questions. Really easy when they are either 0 or 255. So if I turn the red channel completely to 255, then that gives us the pure red. I switch that one off, and we'll try that with green. So 255 there and 255 on the blue channel. Now where it becomes a bit more complicated is when these values are in between. So if I take our 3 channels and drop them all down to around 135, so let's bring the green up to there and let's bring the red up to there as well. So they have to be exactly the same, but when they're all about the same, then we get a grey. So the higher these values are, the lighter the grey is, the lower they are, the darker the grey is. So let's just try that down here. So we've got our dark grey, and if we try that up here, that gives us our light grey. Reason for that is because, of course, we're adding more light as we go along, so the greys get lighter. So the next thing is to put our red to 255, and I'm going to put the other 2 values to both about the same but much lower. And what we get there is a pink colour, which is basically just light red. So we've got the red as our dominant colour here, and then because these other 2 are the same, they will lighten that red. So let's try that for some of the other colours as well. Let's put these down to around the 90s, and then let's bring the green up, okay, and we get that lighter green colour. So if I turn the others off, you can see it comes back to a pure green. If we bring these up, we get that lighter green, and that will work for any of our 3 colours. So as I said in the video there, each of our 3 colour channels goes from 0 to 255. What this means is that we've actually got 256 values for each colour, because we've got 1 to 255, but we've also got the 0 value as well. So this is an RGB colour cube. So this represents RGB colour space with all the colours in there. Down here we've got our 0, 0, 0. Don't think of this like a graph. So if we go along the x-axis, then we're now at this point we're at 255, 0, 0. If we go up the y-axis, we haven't gone along the red and we haven't gone back towards the blue, we're at 0, 255, 0, so our pure green. Along this axis here, then we would end up with 0 red, 0 green and 255 of blue. If we let the cube rotate, we can see our different colours on there. And at the very top we've got the white for 255, 255, 255. Now in binary, number 255 is 8 ones, so it's an 8-bit number, it's the largest 8-bit number. And this gives us what we call 24-bit colour, because we've got 8 for the red channel, 8 for the green and 8 for the blue. So in order to see how many colours we can make with the 256 different values for red and green and blue, we multiply them, which gives us 16,777,216 colours. So we usually say about 16.7 million. Remember again about our binary number then, when we have a 24-bit binary number, we can use that to represent any colours in the RGB model. So for example, for blue, we would have 8 zeros, 8 zeros, 8 ones. Probably wouldn't have the spaces between them, it makes it easier for us to read them. Because of course they represent 0 in the red channel, 0 in the green channel and 255 in the blue channel. Now load up the last set of questions and answer those. Go back on the video if you need to do at any point.